Hello there, this is Joseph's Industrial Economics. This is the first video of Module 2, the boundaries of the firms. How does a firm determine its boundaries? The boundaries may refer to how many volume of products is produced. It is the decision of quantity. How many kinds of products is produced. It is the decision of variety. How many processes the products have from material to final goods. The answer of the first two questions define the horizontal boundaries of the firms. The second one define the vertical boundaries of the firms. We start with horizontal boundaries. In this video, you will learn maybe the most important concepts and principles of microeconomics applying in industrial economics. The first two questions, how many volume of products does a firm produce? How many kind of products does a firm produce? These questions are decision-making problem of quantity and variety. In some industries, like microprocessors, airframe manufacturing, large firms dominate. In other industries, like website design and shoe production, small firms are the norm. Some industries, such as beer and computer software, have large market leaders like Microsoft, and small firms fill niches like Blizzard Entertainment. What is the factors to determine the size of the firm? So, we will discuss essential concepts which include economies of scale, economies of scope, learning curve, and diversification to illustrate the determinant of horizontal boundaries of firms. An informal description of economies of scale and scope is bigger is better. We have reviewed the economies of scale in our economics primer. It is defined as when average cost declines over a given range of output. In Figure 2.1, a U-shaped average cost curve depicts that as the production volume is small, the process exhibits economies of scale, whereas output increased, the average cost declined. It is mostly because the fixed cost is spread over increasing output initially. When the volume of output is very large, the production beyond capacity constraint, the process exhibits diseconomies of scale. The average cost increased by increasing output. This U-shaped cost function is rarely observed in empirical studies. Instead, a L-shaped cost curve that as the output is beyond the minimum efficiency scale, the cost function exhibits constant return, is more common. The definition of economies of scope is about the variety of products. The economies of scope exist if the firm achieves savings as it increases the variety of goods and services it produces. Let's explain it with mathematical formulas. Suppose a firm can produce two different products, X and Y. The production process exhibits scope economies if the total cost of producing Qx units of X and Qy units of Y at the same time, which is Tc of Qx, Qy, is smaller than the total cost of producing Qx and Qy separately. That is, Tc of Qx, Qy is smaller than Tc of Qx0 plus Tc of 0 Qy. The formula can be interpreted as to produce Qx of X and Qy of Y. It is cheaper to produce them in one firm rather than produce Qx of X in one firm and produce Qy of Y in another. It can be rearranged to show another interpretation. Suppose the cost of production nothing is 0, which is Tc of 0 is 0. We have Tc of Qx, Qy minus Tc of 0qy is smaller than Tc of qx0 minus Tc of 0, 0. This says that the incremental cost of producing qx units of goods x as opposite to none at all. The right-hand side of the inequality is lower when the firm is producing a positive quantity qy of goods y, the left-hand side of the inequality. In business, the strategies of leverage core competence or compete on capability equals to recommend firms to exploit the scale economies. Let's see some examples. Tesco, a British giant supermarket, uses its capacity of warehousing and distribution to expand the market to different countries. Apple, the biggest electronic manufacturing firm, uses its excellent design and skill on engineering to make popular phones, laptops, and tablet computers. IKEA, the world's largest furniture retailers, makes almost all items of furniture by their unique and consistent style. It might cost IKEA more to buy the beds than make itself. The economies of scope is one of the reasons why Apple uses the chip designed by itself rather than, like competitors, buy chips from Qualcomm. A more intuitive example is the shape of capsule machine. You may see one or two capsule machines in front of the convenience store or stationery shops where kids may go into. In some big cities, there are shops for capsule machines. There are hundreds of capsule machines for different models in it. This kind of shops can save in cost for capsule providers to collect money, refilling, and advertising. With these definitions, we then identify the sources of scale and scope of economies. The spreading of fixed costs may due to specific products, especially for the cost of machinery, research and development, and the training of workers. Even a simple production process may require substantial fixed cost. Let's give a numerical example of the aluminum can production. Suppose the full automated setting is cost $50 million. Suppose the annual interest rate is 10%. The fixed cost of this automated plant is $5 million per year. At the full capacity, suppose it can produce 500 million cans per year. The yearly average cost for this plant is 1 cent. If the plant operates in 1/4 capacity, that is, only 25% of the can produced, the average cost is then 4 cents per year. The cost difference of 3 cents per can is a huge gap in the competitive business environment. The spreading of fixed costs may also due to the trade-off among different technologies. Take the aluminum can production as an example again. The small firm with 1/4 output, 125 million cans, must suffer the high cost disadvantage, right? Not necessary. Suppose the firm chooses a partial automated technology on production. The cost of half auto setup is $12.5 million. Also, it bears a higher variable cost, say for labor, 1 cent per can. The average cost of two different technologies is summarized in Table 2.1. If the volume of output is large, 500 million cans per year, the average cost of full automated production is 4 cents per can, which include the spreading of fixed cost 1 cent and the cost of materials 3 cents. Meanwhile, the average cost to partially automated production is 4.25 cents per can. Although the average fixed cost is reduced by 0.75 cents, but the emerge of labor cost 1 cent per can makes the average total cost higher in partial auto plant than in full auto plant. If the volume of output is small, 125 million cans per year, the average cost of full automated production is now 7 cents per can due to the enhance of average fixed cost by 3 cents. On the other hand, the average cost of partially automated production is 5 cents per can due to a lower average fixed cost. As you can see, at this example, the large scale of production with full automated plants is still the most efficient way. Figure 2.3 depicts the average cost curve of two different technologies of production. The steeper green curve, SAC1, is the average cost curve of full automated plant. The flatter black curve, SAC2, is the average cost curve of partially automated plant. If the production volume is at 125 million cans per year, SAC1 exhibits an excessive fixed cost comparing to SAC2. If the production volume is at 500 million cans per year, SAC2 exhibits an excessive capacity cost. This induced the concepts of long-run economies of scale and the short-run economies of scale. For given technology, we see it as a given capacity. The average cost decreased as the volume of outputs increased. This is observed both in the full automated and the partially automated plant. That is, in the short run, the economy of scale exists. In the long run, the firm chooses higher capacity to enjoy the reduction on variable labor costs, makes the economy of scale on the large amount of production. The firm should choose a capacity to meet its need of production, where the decision is made by the rule of marginal revenue equals marginal cost, to chase the long-run efficiency of production. Figure 2.4 illustrates the distinction between long-run and short-run economies of scale. For both SAC1 and SAC2 exhibit economy of scale. The slope of average cost curve is downward sloping. These are short-run economies of scale. And the black lower envelope curve of 2SAC is the long-run average cost curve. This black curve is also downward sloping, which is long-run economies of scale. The full automated aluminum can production is an example of capital-intensive production. A production process is capital-intensive if the cost of productive capital, such as factories and assembly lines, represents a significant percentage of total cost. Most of productive capital, such as machinery and computer servers, are indivisible. So, the indivisibility are more likely happened when the production process is capital intensive. On the other hand, when most production expenses goes to materials and labor forces, the production is material or labor intensive. Because the materials and the labor forces are divisible, the average cost in labor-intensive industries mostly exhibits constant return to scale, a horizontal line of average cost. Although we can treat labor cost as variable cost mostly, some of the expenses on workers are fixed. For example, the travel expenses, which is not dependent on the volume of output, is fixed for a given period of time. There are two rules of thumb to summarize our discussion of indivisibility. Substantial production-specific economies of scale are likely when production is capital-intensive. Minimum product specific economy of scale are likely when production is materials or labor intensive. The economy of scale is related to the concept of specialization. In Athens myth, the wealth of nations, the division of labor is limited by the extent of the market. This is because in a more detailed specialized process of job, the more precise investment is needed. For example, a general surgeon needs to invest more time and effort for becoming a thoracic surgeon in the example 2.2. This investment is a fixed cost for surgeons, which is the investment is independent with quantity of surgeries. So, a steeper average cost of thoracic surgeons is as the full automated plant in the case of aluminum can production. Similarly, the specialized surgeons will be needed if there is a large market. Okay, in next video, we will provide some special sources of economies of scale and scope. Thanks for watching.